what we're gonna do, we have 1, 2, 3, 4, 5, 6, 7, 8 points, guys, X and Y, order pairs. As you can see, for each X, there is a Y, X, Y, X, Y. We're gonna plot the points and come up with what we call a scatter plot. It's just like I did by hand when I plotted points. Now we're gonna let the calculator do that. So what I'd like you guys to grab your calculator and do what I'm gonna do right here. So we're gonna do it. This is my calculator. I'm gonna go to stat. So let's go to stat, edit, and L1 and L2. I'm gonna clear L1. This is how you clear it. You just highlight L1 and hit clear and enter. I'm gonna clear L2. Okay. In chapter 9, guys, L1 is gonna be your X and L2 will always be your Y. So let's enter the values in there. 5.2, 7.3. All right, guys. So I put the X values in L1, the Y values in L2, and I think you should agree with me that there are 8 points here. The first one is called 5.2, 3.3. The second one is called 7.3, 5.9. The third one is 6.7. I'm gonna write them down, 4.8. 1, 2, 3, 4. 5.9, 4.5. 6.1, 4. 8.3, 7.1, and I got 2 more, 9.5, 5.5, 3.6, and then 7, 6.1. And I hope that you are working with me on this, guys, because this is what you will be doing, you know, when you take the test and try to answer questions from this chapter. Always the first part is to put the data in L1 and L2. This goes to L1, so X goes always to L1 and Y goes always to L2. Okay, the first question is do a scatter plot. Plot the points. You don't need to do this by hand. We could do it by hand, but it's ugly and it has a lot of decimals. So we're gonna ask the calculator to do a scatter plot for us. You don't need to take notes how I'm doing the scatter plot because it's all explained, guys, in this handout. So if you miss a step, you can go back later to the calculator, to my handouts and see how I did it. So here's what we're gonna do to do a scatter plot. We're gonna press the second key and then the Y. And we're gonna press enter. And we're gonna make sure that plot 1 is turned on. So it is turned on. And then we're gonna go to type and select the first one, guys. The first one is the dots, the scatter plot. The scatter plot will plot the points for us. So you only select the first one. Now we need to confirm that our data is in L1 and L2. You can see, guys, my data is in L1 and L2. And now you can quit. How do you quit? After you make sure that your stat plot is turned on, you just press the second and quit. And let me show you how to show the scatter plot. You go to zoom and you scroll down to number 9. Zoom stat. Press enter. And you can see your scatter plot. Any questions here? Do you feel that there is a relationship between X and Y? And if yes, is it a positive relationship or a negative relationship?
Yes, it looks positive.
It looks positive, I agree. Because as you notice, as X increases, y increases, and they seem to belong to a line of best fit. So this relationship, guys, it's called a positive linear relationship between x and y. Now, x, guys, is called the independent variable. And they call it also explanatory variable, right here. Y is called the dependent variable because it depends on x. And it is called the response variable. So explanatory is x and response is y. And if you guys ask me to draw the line of best fit for this, I think it's going to be probably something like that. That is a line of best fit. And you're going to see, guys, shortly how the calculator can create this line of best fit. The y equals mx plus b, the calculator is going to do it for us. It's going to find the slope, it's going to find the y-intercept, it's going to do everything. So any questions, guys? All right. Let me go to the next page now. Okay. Let me show you. And we're going to graph it. So I'm going to quit here. Okay. There's one thing we're going to do on this calculator, guys. You do it once and for all. And if for any reason later you reset your calculator, you have to go back and do this again. So let's do this. I would like you to press the second key and then number 0. So I'm going to go back to 0 right here. And here's the calculator screen. You have access to what we call a catalog. And I would like you to scroll down until you see the word diagnostic on. I'm getting there, right here. Press enter twice. You must do that in order for this calculator to be capable of performing the tasks of chapter 9. So the only time you have to do it again, guys, if you already did it with me, is if you reset your calculator, then you have to do it again because this is going to reset if you reset your calculator. And let me show you.
Do it one more time.
Yes, sure. Let's do it one more time. So assume I didn't do it. Press the second key. I'll go slow, guys. We have plenty of time. We'll finish chapter 9 this week. So second key, and then you go to number 0. Click on it. You get this. Scroll down to diagnostic. On. Here you go. You see when the arrow points to diagnostic on, and then hit enter twice. And that should be it. The calculator will find now the equation for us of the line of best fit, which is called y equals mx plus b. The only thing in this calculator, the one who wrote this program did not call he called it a. So it is ax plus b, which is very much, the same thing. So let's do this together, guys. Put stat. So press on stat, calc. And I'm going to let you guess what feature we're going to go to based on the title of our chapter, what we've been doing. You used number 1 in chapter 2 when we did the mean and the standard deviation. We never use number 2. So what do you think we're going to go to now? Which number?
4.
Number 4.
4, yes, linear regression. You can see the AX plus B. So if you guys, even if you had no clue, and you know your instructor has been talking about y equals AX plus B, you can tell it's going to be in the linear regression. Okay. If you have a newer calculator, it's going to ask you the X list is in L1, you confirm that. The Y list is in L2, just confirm that. But if you have this calculator, that's it. That's all you have to do. Just press enter now. And can you see the equation, guys? It says y equals X plus B. I'm going to write it down. It gives me A to be, I'm going to do it to 2 decimal places, 1.26. And B is going to be negative 3 point, if I round, it will be negative 3.30. And I like it to write the value of R squared and R. I'll explain them later. And R squared is 0.94. Any questions, guys? Please ask me if any questions. Usually when you do problems, and this one, the first question, he will ask you find R. The second question, he'll ask you to find R squared. A third question, he will ask you to find the equation of the line of best fit. And you guys, you can see we've done all of them in one shot. But I need to explain what R and R squared mean in a second. We're coming to this. No questions? All right. So I'll move the calculator aside. Okay, so what would be the equation of the line, guys? Let's write it down. AX plus B. Plug in A by its value, which is 1.26. Plus B, which is what? Minus 3.30. And this is the equation. So if you are asked to find the equation of the line, guys, here it is. A is the slope. And this is the y-intercept. All right. Now let's show you guys how we can graph this, put it on the calculator, the equation, we draw the line. So I'm going to go back to my calculator, guys. I'm going to go back to Zoom 9. And here's the scatter plot. Now I'm going to show you the line. Okay, let's do it together. All the directions are given in the handout, guys. So I like it to press on y equals. Well, in order for the calculator to show the line, guys, you have to provide the equation. It's in y1. All we need to enter, guys, the 1.26x minus 3.3. You already have the y here, which is called y1. So here's how I'm going to do it. So I'm going to put 1.26 and x. Look, this is the x right here. Don't forget the x minus 3.3. And I would like it to hit the graph. And you're going to see magic here. This is the equation of the line, and this is the line of best fit. So this is the best line that will fit all the points. You could not find a better fit than this. It is called the line of best fit. So again, here's what I did, guys. I'm going to do it one more time. I pressed on Y. Then I entered the equation 1.26, and then I put X. Then I did minus 3.3. And then I hit graph right here. With practice, guys, you'll get used to it. So it's this is the equation of the line. Okay. This is called, as I told you, line of best fit. Or regression line. Or, so whatever, if he asks you to find the equation of line of best fit or regression line or line of least squares, this is the same thing. It's a line of best fit. Any questions, guys? Okay. Now we're gonna explain the meaning of R 0.97. What does it mean here? So you can see, guys, this is the equation right here. I use a different software, to generate the equation of the line. Okay. So what you learned so far, guys, how to plot points on the system, X and Y coordinates, and how to find the equation of the line, which is y equals ax plus b or mx plus b. So a is m here, guys. It's okay. Whomever programmed this didn't like to put m. He put a, so that is fine. And you learned also how to sketch, just a line and see how it passes through the points. Now I'm going to go to interpret the meaning of R and R squared. And actually, after I do that, there is only one more thing, and we will be done with this chapter. And the previous question, 0. what?
0.97.
Yeah. Do you guys agree with me that this 0.97 is very close to 1?
Yes.
All right. Here's how we determine what R means. R is called correlation coefficient. And if you have your diagnostic on, as I did earlier, then it's going to show. If you don't have the diagnostic on, if you didn't do it while I was doing this, guys, and you try to find R, it's not going to show with the equation of the line. So you have to make sure your diagnostic is on. Here is how you interpret R, guys. That's how important R is. If R is very close to 1, we say that there is a strong positive linear correlation between X and Y. Correlation or relationship here. If R is very close to -1, we say that there is a strong negative linear correlation between X and Y. If all the points that we have happen to be right on the line, then R will be perfect, will be a perfect 1 or a perfect -1. Let me give you an example of a perfect 1 if you have it like this. Here, if you do R, guys, it's going to be 1. You want to see a perfect -1? It will be like that. But in life, we don't get that kind of perfection. So R here will be a -1. If all the points fall on the line, then R is 1 or -1. If R is close to 0, then the linear relationship is very weak, guys, here. So if you get R like, let's say, 0.1, you can conclude that the linear relationship is weak. There is no strong linear relationship. We will not calculate R by hand. You can use a calculator to find the value of R, and which I've already done that. And these are the steps, guys, and how to find the value of R. This is what I did. Okay. Now I'm going to pause for a second and I'm going to open the book and I'm going to show you some graphs and I'm going to ask you to guess the value of R. So if there is a perfect positive linear relationship, R will be 1. If there is a perfect negative linear relationship, R will be -1. If it is close to 1, we have a very strong relationship between X and Y. And if it is close to -1, we have a very strong linear relationship. R cannot exceed -1, doesn't go beyond -1 and 1. It's always between -1 and 1. Just 1 second. So I'm going to show you some scatter plots. And can you guys guess the value of R right here? What would R be? Right here. Yes, that should be easy.
Yeah.
Strong positive linear.
Yeah, but what's R? What's the value of R? Do the points fit perfectly on a line, all of them?
Yes.
Yeah,
And
it's 1.
It's 1. Okay, that's 1. That's perfect. Now, the other one, you cannot guess exactly, but you can give me an estimate. What do you think R is? Do you guys agree with me? This is a positive. It's not perfect, definitely. So it has to be less than 1. Can you guys give me a guess? 0. What? It's not going to be a 0. What?
99.
99. That's 2. That's almost perfect. It doesn't look like they're really nice, perfect there. So probably it's less than that.
0.8.
8. Let's see. Wow, you nailed it. With 0.81. Okay, what about this one? This one, guys, you agree it's weaker than this one, so it's not going to be as high as this one. So any guess? Doesn't look like it's really linearly connected, but there is some kind of relationship, but I think it's kind of weak. Any guesses?
0.7.
Okay, well, probably you were too.
0.5.
Okay, let's see. Oh, good. 0.545, which is close to 0.5. Okay, let's go to the next ones. Okay. A possible question on the test, guys. I can give you 2 graphs and ask you which one has a higher value of R. So you should be able to tell from the graph itself. Okay. Do you guys agree with me that the linear relationship is perfect here, but it's going down? So what's R here? You should tell me the exact value of R here.
-1.
-1. Very good. Look, it's -1. Here, they seem to be related, but negatively. There is a strong negative relationship between X and Y. What do you think R is, guys? It's negative.
-9.
-0.9. Let's see. Good job. -0.92. Excellent. Okay, that looks weak. What do you think R is here?
-0.1.
Okay. And it is 0.04. It's very weak relationship. Okay. So let's show you some more graphs. I'm sorry, I should have make it a little bit. So these are the answers. Good. I'm not gonna start doing a problem before we have a good grasp of. What do you think about the relationship between X and Y here in number 9?
Negative linear.
Negative linear correlation between X and Y. Yes, strong, actually. Strong negative linear correlation between X and Y. What about number 10? Do you see a line there? Do you guys know what we call this curve? I don't know if you've seen it in algebra before. It's called a parabola. And when you see a curve, just like this, that's not linear. So you can say non-linear relationship between X and Y. You see, he says non-linear option. This is non-linear. We're interested in linear in this chapter. What about 11, guys?
-1.
-1, perfect. You can say it's a perfect negative linear relationship, correlation between X and Y. 12.
No linear correlation.
Or you can say weak, very weak linear correlation between X and Y. What about 13?
Positive linear equation.
Positive, very strong. That could be 0.95 or 96 or 97. A positive, strong correlation between X and Y. And what about 14, guys?
Is it a positive 1?
Yes. So what do we call it? What's the magic word here? Starts
Perfect.
with P, perfect linear correlation. So this is, you should be able to answer, guys, by just looking at the graph here. In exercises 15 to 18, the scatter plots show the results of a survey of 20 randomly selected males ages 24 to 35. Use age as the explanatory variable. So age is X, the X value. Match each graph with the appropriate description. So you have 4 descriptions, guys, and 4 graphs. We're gonna match each description with its graph. So here you can see as the age increases, this is in thousands of dollars, it does increase. What do you think that would be? Remember, age is the X always. Do you think this would be the body temperature, the balance on student loans, the income, or the height? Do you think your balance on student loan increases as you age or decreases?
Decreases?
Decreases because you're paying it off. Do you think your temperature will increase as you age?
No.
No, it's not supposed to do that. Do you need your height increases after you age,
No.
after you are 24? No, it will not. It will not. Actually, your height will go a little bit down, if you have some back issues later. So what do you think 15 resamples? Age and what? So what's 15? Age and income. With more seniority, guys, you get paid more. That's what most of the places are. So there will be age and income. Okay, let's go to 16. What do you think 16 represents? So age and income, we're done with it.
Would that be a scatter? I don't know.
So which one is 16? We're doing 16 now.
Oh.
Is that body temperature?
Age and body temperature, but the body temperature can go to 65, can't go as low as 65.
Oh, yeah.
That's dangerous. And the body temperature is not supposed to fluctuate like this. So the 65-inch, it looks like 65 inches to 78 inches. So that probably in inches. So that will be what? The height. And you notice that the height might go a little bit down with age, because if people start to having some back issues, they wouldn't even to stand up straight, anymore. That's why, just it shows the height goes a little bit down probably. So that's age and height. That should be easy now. We're left with age and balance on student loan and age and temperature. You can see that there is a negative relationship here, guys. As you move to the right, the Y goes down. What's supposed to go down, just with the year, after so many years, after you graduate from school, is what? Your student what? Loan. And you can see eventually it will come down to 0 because you have to have a balance of 0 after 10 years. The reason you see from 24 to 35, because usually students' loans are paid off in 10 years. So this is the student loan. And there is a strong linear correlation between X and Y. Do you guys agree with me that 18 should be the age and body temperature? You see, it's around 97, 98. It should not change. Everybody, we all have pretty much the same body temperature. It's right here. So these are all examples of correlations between X and Y. Okay? Any questions here? You might see this same exercise in the homework online, so you already done it. You will see 4 graphs and 4 statements. Just match each graph with the statement. All right. So now we're going to do this exercise that covers pretty much everything I've been talking about. And one more thing in addition to that. And if you have a good grasp of this exercise, you should be able to do everything in chapter 9. So the first thing, guys, I'm going to pause for a minute or two and ask you to put the X values in L1 and the Y values in L2. So again, one more time. To find the scatter plot, guys, you just do zoom and then number 9. That's the scatter plot. And to find R, you go to stat, calc, number 4, and just press enter. And it's not only it's going to give you R and R squared, it's give you the equation of the line, which let's write it down because we're going to need it in the remaining questions, guys. So Y equals AX plus B. My A is negative 0.963 and my B is 17.296. My R squared is 0.94 and my R is negative 0.97. So I already found R for you, and this is R, guys. Using the calculator by following the steps above, R is negative 0.97. Since R is very close to -1, then we say there is a strong negative linear relationship between X and Y. And if you want to mention what X and Y is, X is age of the child, and Y is the number of irrelevant responses on a standard test. Okay, the next question, guys, is to find the equation of the line of best fit. Use your calculator and the steps explained above to derive the equation. We already did it, guys. It's already there, right here. Y equals AX plus B. So let me write it down. And A is negative 0.963. X plus 17.296. Now you notice a hat right here on top of Y. The reason why we use a hat just to say that this was generated from a sample. So always when you write your Y value, your equation, just put a Y hat just to say that this is from a sample, not from a population. We only have a sample of responses from different students. How many were there in the sample, guys? Here you go. How many ordered pairs? we have 1, 2, 3, 4, 5, 6, 7, 8, 9. 9 pairs. X and Y, X and Y, X and Y, X and Y, and so on and so forth. Okay, so any questions about finding the equation of the regression line, guys? All right. One more thing I want to do, I'm going to skip part D, which is the heart, just of this chapter until next time, and I'm going to talk about R squared. Just tell you what R squared means, and that should be it. So what was R squared? We did it right here, 0.94. Let me explain what R squared means. R squared is called the coefficient of determination. So if I ask you to find the coefficient of determination, I'm asking you to find R squared. So R tells us about how strong the linear relationship between X and Y is and whether positive or negative. And let me explain what R squared is. So I'm going to explain R squared, and then we will wrap this up. I need a sheet of paper. Please pay attention to my explanation, the example that I'm going to use to explain R squared. It's going to make a lot of sense to you. Okay. We're going to take this example: diamond, weight, and price. Let's say we have some data about the weight of some diamonds, pieces, and the prices. Let's say a diamond is 0.5 carat, and the cost is $800. Let's say I have another one which is 0.75 carat, and the cost is $1,200. 1 carat, $2,000. I'm just making this up, but you guys agree with me, as the weight increase, the price of the diamond increase. Another 1 carat, let's say 2,500. 2 carats, 5,000. 3 carats, 7,000. I'm just making this up. 10 carat, probably 20,000, and so on and so forth. Okay, let me ask you a question first of all. Do you guys agree that there is a strong positive linear relationship between the weight of a diamond and the price? Yes
Yeah.
or no? Definitely. Nobody can argue that. We're talking about real diamond, not a cubic zircon. As the weight of a diamond increases, guys, you better believe me, the price increases. And actually, sometimes it increases exponentially. So there is a relationship, between the two. So let's say I found R, and then I found R squared. And let's say R turned out, guys, to be 0.87. Can you guys tell me what R squared is? R squared is 0.87 squared. That's what R squared means. R, quantity R squared. So let's find this one and see what the value is. Squared. Okay, so I got 0.757. Okay, can you guys change R squared to a percent for me? That would be what? 75 point what? 7%. Okay, I'm gonna tell you what R squared means. First of all, R is 0.87, so there is a strong positive correlation between the weight of a diamond and the price of a diamond, because it's very close to one. It's a close to one, not very close. So probably you don't want to say very strong correlation. You can say strong correlation between the weight of a diamond and the price of the diamond. Okay, let me ask you a question. Is the weight of the diamond the only factor that determines the price of a diamond? Yes or no?
No.
No. Other than the weight. What are the other factors? And this is the reason why I use this example, because students can help me with this one. What are the other factors that determine the price?
Color, cut, and clarity.
Good. Color, cut, clarity. These are very important. If you have a yellow diamond, it's very expensive. Shape. These are important, guys. What else?
Whether or not it's man-made.
Okay, man-made or machine-made. Here you go. You know better than me, guys, on this. Probably that's another factor. Anything else, guys, can you think of?
I don't know if where it came from would have a factor or not.
Well, what is it? The man-made or machine-made?
No, I was saying I don't know if like where it came from, location-wise, plays a role in how much they charge for them.
Yeah, well, yeah, that's well, we're not gonna consider that. We're assuming that it's a standard. Yeah, yeah, that could be a factor also. Also, yeah, it depends on the brand name, just store that you're going to. Sometimes, they inflate the price because it's a well-known, just store. So yeah, I do agree that it could be a factor. Okay, so let me tell you what R squared means here. 75, and please listen carefully to me, guys. 70, you can say 75.7%. Let's make it 76%. I want to make it easier. You can say, guys, that 76% of the change in the price in the diamond is due to the change in the weight. 76% of the time. The price will change, not 100% of the time. It doesn't tell us the whole story. 76% of the time, the prices change is due to the change in weights. So what's left from 100%, guys? 76, take it away from 100% is what? 24%. 24% of the time, the change in the price of the diamond is not due to weight. It's due to some other factors, guys, that you listed for me. The color, the cut, the clarity, the shape. So the weight and the price doesn't tell us the whole story. It tells us 76% of the story. But the remaining 24%, and you're not supposed to figure out what's the 24%. But the reason I gave this example, guys, because it's easy for you. We know that diamond is not only the weight. There are some other factors. So those factors make the other 24%, just of the change, explain the other factors that determine the price of the diamond. So that's what R squared. R squared is called the coefficient of determination. And if I want to write it down, guys, I write this. 76% of the variation means change, of the price of diamond can be explained by the variation of the weight. Using the regression model, the regression line. That's how you state, this is the meaning of R squared. You get R squared, you get the percentage, and you can say, 76% of the variation of the Y variable can be explained by the variation of the X variables. I'm gonna go to our example and show you how to state R squared here. So we're gonna leave this till next time. And I'm gonna just find R squared right here. See, I put a lot of details in this example, guys, to explain it in details and how to use the calculator. So R squared, we know R was negative 0.97, so R squared turned out to be 0.94, as you can see here, 0.94. Okay, how do you interpret the 0.94? X is the age of a child and Y is the number of irrelevant responses. So you can say 94% of the variation in the number of irrelevant responses can be explained, by the age of the child. And you can say here, 94% of the variation in the number of irrelevant responses on the standardized test can be explained by the variation in the age of the child using the regression line. There is a 6% that are unexplained. Can you guys tell me what do you think the 6% are, that other factors that will contribute to number of irrelevant responses on a test by a child? What could be the other factors other than the age?
Their mental capacity.
Yes. Whether the child, just was sick or no, whether they were focusing, just on the test. So there are some other factors other than the age, so it could be so many other factors, but they're not many. It's only 6% of the story, but 94% of the story can be explained, just by the age itself. So in summary, guys, the value of R squared is called the coefficient of determination, and represent the percentage of the amount of variation in Y that can be explained by the variation in X. We're gonna do a lot more problems on Wednesday, and there's one remaining part of this chapter that I haven't done yet, which is testing the hypotheses, which for the 5 steps that you've been doing 7 and 8. So we're gonna do that on Wednesday. So on Wednesday, guys, I will review the first 2 parts, A and B, and then I'm going to go to part D right here, as you can see. All right. So that should be it for today. I will be available for office hours around noon, guys. So if you need, you have any